Hello, my name is Matt Gracie and I'm an engineer on the professional services team at Security Onion Solutions. This video is about how to ingest NetFlow data from your network infrastructure to gain visibility into activity on networks that don't have a dedicated Security Onion forward node on them. Sometimes you might have a remote or temporary network that you want to monitor, but you don't want to dedicate a forward node to it. If your router or other network hardware there is capable of producing NetFlow logs, this is a potential solution. To ingest these logs, we'll be using the Filebeat Module functionality that Security Onion introduced in 2.3.60. I'll put links to the documentation in the comments for this video. Please keep in mind that many other Filebeat modules are also supported, so it might be worth your time to look at the Elastic website and see what other information you can ingest from your on-prem or cloud networks. Let's get started. There are 3 steps to enabling NetFlow ingestion in Security Onion. First, we need to update the minion file for our environment to tell it to activate the NetFlow module in Filebeat. We also need to update the Docker configuration to tell it to listen on that port. Next, we need to update the firewall configuration to allow the traffic in from our NetFlow emitter. And finally, we need to build the Logstash pipelines so that Security Onion knows what to do with that data when it's coming in. We're going to step through these pieces and I'll explain them as we go. As you know, everything in Security Onion is configured via SALT. SALT sets the configuration standards for everything in your grid, so that's where we need to go in order to turn on this configuration. So we'll change directories into opt, so, salt stack, local, pillar, minions. The minions files are individual configuration files for all of the nodes in your cluster. In our case, this is a standalone installation running 2.3.80. But if this was a distributed grid, you'd see minion files for all the different nodes in the grid. So let's edit this minion file. And at the end, we'll add the configuration for the Filebeat module. I've already written it up in a separate file, so I just have to import it into VI. And you see it starts with Filebeat. That's the name of our configuration stanza. We're enabling a third-party Filebeat module. The module is named NetFlow, and here are the directives. Log enabled true, NetFlow host 0000, meaning accept it from any host, NetFlow port 2055. So what this is saying is we're going to accept traffic on port 2055, we're going to hand it off to this Filebeat NetFlow module, and from there it'll be ingested into our Security Onion environment. Let's save this. Now we need to check our Docker module or our Docker container that's running Filebeat. So Docker ps grep Filebeat, that will list our running Docker containers and search for the one named Filebeat. We see there's a bunch in here, but if you look, you'll see that none of them are listening on port 2055. So what we really need to do is update that Docker configuration. Now, in Security Onion, you'll see if we look under Salt Stack here, there are 2 directories. There's default and local. Default contains the configuration that comes with the platform by default. So this is something that is updated every time you run SOUP, the Security Onion updater. We don't want to make changes in default because they'll be overwritten the next time a new version of Security Onion comes out. What we want to do is copy that configuration information into local, which is the directory tree for local changes, and make the changes there. Anything that's in local will take precedence over its counterpart in default. So we'll go into local, salt, Filebeat. You see this directory is pretty much empty because, again, we're only using the default configuration right now. We will copy opt, so, salt stack, default, salt, Filebeat, init.sls into the current directory. We'll change the owner to so core, and then we will edit that file. Init.sls is the salt file that tells the system how to build the Docker container. So this is where we need to update and tell it what ports to listen on. If we scroll down here, you'll see there's a bunch of file directories that it makes and files that it manages. And here are the port bindings. So we want to put a space here, space over. This is a YAML file, so you want to make sure you use spaces, not tabs. We want to bind all traffic coming in on port 2055 to 2055/UDP, because NetFlow is a UDP protocol, and as you recall in the minion file, we told it to listen on port 2055. We'll save this. And now we need to propagate those changes. So we tell salt to apply the state, Filebeat. This will take a moment. What it will do is check the configuration file that we just modified. It'll realize that the currently running Docker container is not in compliance, and it will update it. So see, succeeded 51, changed 4. Now, when we do a Docker PS, we can grep for port 2055, and we'll see right there we have so-filebeat has been running for 12 seconds, and it's listening on port 2055. So the module portion of this is complete. We have configured the Docker container to listen on port 2055, and we have configured the module to listen on 2055 for processing the data as it comes in. Next thing we need to do is update our firewall settings. So let's clear the screen. We need to create a host group for NetFlow. So we'll say so-firewall, which is the command line tool for changing firewall settings. Add host group NetFlow to make a host group named NetFlow. We will do the same thing for a port group named NetFlow, and this will hold the configuration for which ports need to be opened in the firewall to let that NetFlow traffic through. We will add our hosts, so include host into the group NetFlow, and we're going to add the whole /24 here. So what this is it's telling the firewall these are the hosts that are emitting valid NetFlow traffic that I want to let through my firewall. And then we will add the NetFlow port, UDP 2055, to the port group named NetFlow. So now we have a host group named NetFlow. It's the entire 192.168.1.0/24 network. We have a port group named NetFlow. It means any traffic coming in on UDP 2055. Now we need to update our firewall configuration to include this port group and this host group. And again, this will be done in our minion file. So we go to opt so salt stack local pillar minions, and we edit our minion file for this standalone installation. We go to the end, add a couple lines here, and then we can import those firewall rules. Again, I've written these in a separate file, so I'll just import it. And you can see here what the firewall rules look like. What we're saying is, in addition to all the default stuff that's in the firewall, we want to add to the Docker user chain, that is traffic coming from the host into Docker, that it should allow the port group NetFlow, so 2055 UDP, to the host group NetFlow. Again, that's our local network, 192.168.10/24. We're going to make the same change to the input chain. So we're updating the firewall from the outside world to our Security Onion host, and then from our Security Onion host to the Docker container running Filebeat. We close that up, save the file, and now we need to apply it. So once again, we do that via salt. We say salt call state.apply firewall, and it will read that configuration information that we just put into the minion file and apply the firewall configuration. If we want to confirm that, we can look at IP tables, list our current configuration with no port name resolution, grep for 2055, and we can see it right there. We have two accept rules for 2055 coming from that network. That means that one of them is in Docker and one of them is in the regular input chain. So all of that is complete. One last piece, we need to generate the Logstash pipelines that will actually ingest the Netflow data. So we do that by executing a command inside of the Filebeat container. So Docker, because we're going into the container, exec, because we're executing something inside the container. We are executing it inside the Filebeat container. We are doing Filebeat setup of the modules with the pipeline configuration. The module name is Netflow, and the configuration file for this is in user share Filebeat module-setup.yml. And I'll put this in the comments for the video as well, so you can just cut and paste it if you need to. So we run this command. It loads the ingest pipelines. We might as well restart Filebeat just to be sure. This will take a moment. Okay, and then that is all updated. We can close this out and see what it looks like in our web console when we add some Netflow data. So if we look in our web console, we can check our hunt view. And if we group by event dataset, we'll see that we now have a new dataset in here called netflow.log. So let's include that so that we're only looking at the Netflow log stuff, and we'll open one of these up. And you can see that there are Netflow items in here that contain all of the information from the Netflow traffic that we generated. The BGP source and destination, the IPv4 source and destination, protocol identifier, etc. So all of the information that is being emitted by your network hardware as Netflow is being received into Security Onion and properly parsed and put into the Elasticsearch backend so that you can access it with Kibana or Hunt. One thing I want to mention, you'll notice it even puts in things like destination IP from the Netflow in the standard destination.ip field. So if you're hunting for malicious traffic across destinations or sources or ports, and you're commingling Zeek traffic from your traditional Security Onion sensors with Netflow traffic from these remote or these lower capability networks, you'll be able to use the same queries and all the data will line up. One other thing, remember that this data is not going through Zeek or Suricata. So if you are using something like MISP to put threat intel in to match against, those rules will not pick up stuff that's coming in via Netflow. However, you can write rules in Playbook that will identify malicious IOCs in your Netflow data. So that would be another way to go after that if you're using Netflow across multiple sources and you want to make sure that you can alert on malicious IPs or malicious ports and identify malicious traffic. Okay, so that is how you would integrate Netflow into your Security Onion grid. I hope this was helpful. I'll put links to all the documentation in the video comments, and thanks for listening.